I don't particularly like PowerPoints. I don't use them very often, but I'm going to make an exception here. Let's talk a little bit about virtual machines and what those are so that you can kind of get a feel for what we'll be doing in this class for our labs. A typical computer setup looks like this. You're very familiar with this. You have some hardware, the computer itself. On top of that hardware, you load an operating system. Windows, Apple, some other Linux, some operating system. And then on top of that operating system, you load your programs. We're familiar with that. However, with a virtual machine, what we're doing is we're adding as one of our programs something called a hypervisor. And I see that Microsoft didn't know how to spell hypervisor, so it said that it was wrong, but it is right. In this case, we're going to be using one called VirtualBox. And the hypervisor loads as a program on top of the operating system. And then within that hypervisor, now you can add additional operating systems. You might have, say, a Windows 7 operating system here, and you can load a Windows 10 operating system on top of it here. And then you can load additional programs within these operating systems. I might have several operating systems at once. I can load say a Windows 10 and a Windows Server and a Linux machine all on this hypervisor, so it can host various different operating systems. Here's some terminology. We call this operating system the host OS. We call this one the guest OS, or sometimes we call these virtual machines. Be careful that VirtualBox is not a virtual machine. That's the hypervisor. The virtual machines are the operating systems that run on top of that hypervisor. Now, there is a class of hypervisors that does not look like this. It looks like this. These are typically used for things like data centers and networking organizations, or maybe a large organization that uses networking, I should say, where you simply have a hardware, usually a server, and then a hypervisor runs directly on top of that hardware. In other words, the hypervisor, in a sense, is the base operating system or the host operating system. And then you can load your virtual or guest operating systems on top of that hypervisor. So you see there's no operating system in between here. This is much more efficient, much faster, and has several other benefits as well that we won't go into now. Terminology, again, you've seen all this already. The hypervisor, that software that allows you to install those guest operating systems. There is a host-based, in other words, sits on top of Windows or some other operating system. And then there's the bare metal type that you put directly on the computer and then put your guest OSs on top of that. So the host OS is that one that's installed directly on your computer. The guest OSs are the ones then that are installed on top of the hypervisor. Here are three popular ones. VMware. It does come in many different versions. The VMware Player is rather nice. It's free. You can actually even build operating systems or guest operating systems in VMware Player, but it does lack some of the networking capabilities that are available in some of the higher end ones, like VMware Workstation, which is a host-based VM hypervisor. And it is not free. I think last I saw it's about $150 or so for a VMware Workstation. And then VMware also runs a whole number, or has a whole number of other bare metal versions that you might use in a large organization for your networking, or in a large data center, or in the cloud networking situation. Oracle VirtualBox is the one that we'll be using in this class, and that's a free host-based hypervisor. So that's kind of nice. It does have networking capabilities and so forth. Hyper-V is one that's actually built into Windows. Windows Server 2016 has it built in. Windows 10 has it built in. You cannot simultaneously run VMware or VirtualBox and Hyper-V. When you try to enable Hyper-V in Windows, it will detect one of the others is there, and it will say, I can't even install. So you can't really run that simultaneously. Here are some things that are really important about virtual machines that we really have to understand. When you create a guest operating system, the first thing the hypervisor does is grabs a giant chunk of your hard drive. It actually creates a file, and that file is a virtual hard drive. So you might have a 40 or even a 60 gigabyte file that is now used up on your hard drive. And if you only have maybe a couple hundred or even 500 gigabytes, and you have very many of these virtual machines, you can see that it can take them up take up that space very rapidly. So 3 or 4 virtual machines and you've wiped out your entire hard drive. So I usually recommend something like a portable drive that you can carry around, maybe a 1 terabyte drive or even a half a terabyte drive. It does cost money, but it's the easiest way to carry around these virtual machines without having the difficulty of using up your drive space. Keyboards, mice, DVD drives, USBs at any given moment can only belong to the virtual OS, that is to say the guest OS, or to the host OS. Obviously, if I'm typing on the keyboard, I don't want it to type in both the guest and the host at the same time. That would be silly. If I'm moving the mouse, I don't want it to move around in both of them. That would be silly. And so at any given time, I have to switch back and forth and say, well, at this moment, the mouse belongs to the guest, and at this moment, the mouse belongs to the host. So that that's a consideration and just something you have to be aware of. Memory and CPU is a really tricky one. When you set up a guest OS, you say, I'm going to give it X amount of memory. Let's say that I give it 2 gigabytes of my RAM space. Well, if I have a 4 gigabyte system, half of my RAM is now going to the guest and the other half is going to the host. And I cannot simultaneously use that RAM for both. So you're giving up a bunch of your RAM, and that's going to slow your machine down considerably. The same thing is true of CPU. If I have 4 cores and I give 2 of those cores to my guest, then they are unavailable to the host as long as that guest is running. So again, you're giving up system resources to that guest. Because of that, the speed of these guest operating systems, and of your system for that matter, really slows down. So if I have say I have a Windows 7 machine that's got 4 gigabytes of RAM, and let's say I've got 4 cores in my CPU, and I give 2 gig to the guest, 2 gig to the host, and 2 CPUs cores to the guest and 2 CPU cores to the host. My system is going to be basically cut in half, but actually it's even worse than that. It actually slows down even more than that, more than half for each one. And if you have 2 or 3 guest OSs running at the same time, say you're running a little virtual network in your computer, now it's going to be really slow. 2 or 3 of these things and your machine will run at a crawl. So you have to be very patient when you click something, and you just wait and you wait and you wait until it finally clicks in. The more powerful machine you have, the better. When you're running virtuals, really a very, very powerful machine is ideal. If you can go out and, if you have a machine that runs 16 gigabytes of RAM and 6 cores or something, that really is an ideal situation for virtuals. Although you can run it on a lower end machine, it just slows things down. All right, we've gone a long time. Let's shut this thing down now, and I hope this has been helpful in understanding virtual machines a little bit.